although we haven't been using these words specifically. Oh, whoops, that's the, this question right here is at the end. I didn't mean to have it up right away. So although haven't been using these words specifically, we've actually been talking about ratios and proportions. So a ratio is a relationship between two numbers. And that's kind of what we've seen. You know, we've had 2/3 or something like that, and then a proportion is setting a ratio equal to a ratio. So, like if 2/3 equals 4/x, this is a proportion. So we have a lot of practical examples of these, but one where where you very well may be familiar with is what we call aspect ratio. In fact, you've probably, even here on YouTube, you've probably seen things concerning aspect ratio. But like, let's say you go to Best Buy and you're looking for a TV, and it says that it has an aspect ratio of 16 by 9. 16 by 9 aspect ratio. Uh, what does this mean exactly? Does it mean size of the TV? Does it mean it's 16 inches by 9 inches? Well, no, because whether you get a 22-inch screen or a 52-inch screen, it's going to be 16 by 9. So what that really means is the length of the length of the TV compared to the height of the TV. So if you take the length over the height, it's going to be. Now, there may be some more industry standards that I'm not aware of exactly how they mean, but the basic idea is that the length over the height is going to be the same thing as 16 over 9. And if you have an older TV, like an SD TV, standard definition TV, it will have a 4 by 3 aspect ratio, which just means it has something sort of like this. I mean, it's obviously far from perfect, but it'll be the length over the height will be 4 by 3 instead of 16 by 9. That's just a quick example of what you do with ratios, but another application would be something like conversion rates. So let's say we have, for example, we have conversion rates. So if we have $1 is here's a second. $1 is 0.7663 euro. So, whoops, new line. So that's something that I looked up yesterday on Google. That changes pretty rapidly, but when I looked it up, $1 was 0.7663 euro. So something that's kind of important to understand is this means that if we go into some place in the airport that changes your money, if you give them $1, they'll give you back 0.7663 euro. Well, if you give them $2, that means they're going to give you back twice as many euros, right? Because $2 will be worth twice as many euros as $1, so it's 1.5326 euro. Because that's twice as many euros. But what we can do is we can write this as a proportion. See, the proportion of US dollars to euros remains the same. So this will be 1 US dollar to 0.7663 euro. So $1 to 0.7663 euro. But this proportion will actually be equal to, this ratio will be equal to $2 for 1.5326 euro. If you divide these out, they're going to work out to be the same thing, because if we double the amount of, so let me put this: we have $1 for every 0.7663 euros. So that means if we double the amount of US dollars, we'll have $2 for 1.5326 euro. So that means that the ratio stays the same no matter how many US dollars you have. And we can use this knowledge to do our own conversions. Like, let's say we have twice as many euros for this. What if we have, let's say we have an unknown amount. Let's say we have 4 US dollars, and we need to, let's make it 4.5, just make it a little bit more complicated. And we need to figure out how many euros that is. We know how many US dollars we have. We need to figure out, if we trade in euros, how many euros is that going to be. So, what we can do is we can cross multiply. We'll have this y here, so we'll have 1 times y, and this 4.5 times 0.7663, and then we can pull out a calculator. I'll just go ahead and pull out this calculator. So I'll go ahead and clear this off, and so I can have enough room to have, this is kind of a big calculator. So 1 times y, I think we can agree that that is going to be equal to just y. And then this 4.5 times 0.7663. So 4.5 times 0.7663, that comes out to 3.4853. So that means we have 3.44835. So that means if we give them $4.50, they're going to give us 3.44835. It's probably going to round off to, I'm guessing, 3.45 euros. So that means that we've now solved how many euros we're going to get if we have 4.5 US dollars. So let's do another problem. Let's say instead of knowing how many euros we have, knowing how many US dollars we have, we know how many euros we have. So let's say we have 5.73. Oops, I put that in the wrong place. We have 5.73 euros. We need to figure out how many US dollars that is. Well, we cross multiply. I will go ahead and tell you right now, for this particular problem, since x is already in the numerator, you can just go ahead and just multiply both sides by this 5.73. The cross multiply is most effective whenever x is, the unknown is in the denominator, but either way, cross multiplying will still work. I'm just saying that in this particular case, multiply both sides by 0.573, not 0.573, 5.73, excuse me. And then you will find that this is going to be equal to 1 times 5.73 over, and then we still have the 0.7663 euros. I'm kind of leaving off the units. For different classes you may be required to do that, but for this particular class we don't really care about units for this particular subject. So then we have 5.73 over 0.7663, so we'll go ahead and divide that out. 5.73 over 0.7663, and that is about, I'm going to approximate this, it's about 7.4775. So this is about how many US dollars we'll get back if we give them 5.73 euros. So let's go on to, that's good for conversion rates. Let's try this example, the example that I accidentally wrote at the beginning of the video but didn't mean to. So let's say I traveled 71.4 miles on 4.2 gallons of gasoline. How many gallons do I need to make a 100-mile trip? Well, so that means that the ratio is going to be 71.4 miles for 4.2 gallons of gasoline. So this ratio does not change whether the gas mileage of a car does not change whether you go 10 miles or 100 miles. So that means if I go 71.4 miles, the miles per gallon is going to be the same based on no matter how far I go. So that means if I need to make a 100-mile trip, I need to figure out how many miles, how many gallons of gasoline I'll need. So that means I'll have 100. And our known is we have a 100-mile trip, and we're going to be going X gallons. We're going to be using up an unknown amount of gallons. That's what we're trying to figure out. So we cross multiply. So that means we would have 71.4 x equals, and then 4.2 times 100 is going to give us 420. Then we can divide both sides by 71.4. And we'll get that x is equal to 420 times 71.4. And I'll bring out the calculator again. 420 times 71.4, and that comes out to about 5.88 gallons, which should make sense because if it took 4.2 gallons to go 71.4, it's going to take a little bit more to go 100 miles. Alright, that concludes this particular video. I will see you in the next video.